Valves are a crucial component of the combustion chamber. Inadequate sealing of the valves can result in high temperature, high-pressure combustible mixtures eroding the valve and valve seat working surfaces, leading to pitting, burning, and carbon buildup on these surfaces. Additionally, insufficient sealing of the intake and exhaust valves can cause reduced cylinder pressure, which negatively impacts engine performance and efficiency. This lesson will use the Changgu or 180 diesel engine as an example to perform a valve inspection. The inspection methods for intake and exhaust valves are similar. Preparation before operation. The tools required include a scraper, rags, a vernier caliper with a range of 0 to 150 mm, an external micrometer with a range of 0 to 25 mm, a cast iron workbench, V-blocks, a dial gauge, and a gauge stand. Step 1. Use the scraper to remove carbon deposits from the valve head and clean it with a rag. Note that the scraper should not be used on the valve stem, as it is chrome-plated to enhance wear resistance. Scraping it can remove the chromium coating. Instead, solvents should be used to clean the valve stem without scraping. After cleaning the carbon deposits, check the valve seat area for pitting. Inspect whether the valve stem is bent, pitted, or severely worn. Step 2. Measure the valve stem diameter using an external micrometer in 3 sections: top, middle, and bottom. Measure each section in both horizontal and vertical directions. Compare the smallest measured value to the standard value, which can be taken from the unworn part of the valve stem's end. If the wear exceeds 0.1 mm or if there is significant step-like wear, the valve stem should be replaced. Step 3. Measure the thickness of the valve head edge using a vernier caliper. If the edge thickness is less than 0.8 mm, replacement is recommended. A reduced thickness of the valve head cylindrical part increases the combustion chamber volume, affecting engine smoothness and reducing valve head strength. Additionally, during the valve's contact with the seat, high shock waves can cause vibration, which may lead to erosion of the sealing area. Step 4. Measure the wear at the valve tail end using a vernier caliper and compare it to the standard value. If the wear exceeds 0.5 mm, replacement is recommended. Before using the vernier caliper, ensure it is properly zeroed. Step 5. Measure the total length of the valve stem and compare it to the standard value. Replacement is suggested if the length is less than the standard by 0.5 mm. Step 6. Set up the cast iron workbench and V-blocks, and place the valve stem. Inspect the appearance of the dial gauge and ensure it moves freely. Attach the dial gauge to the gauge stand and position it appropriately on the cast iron workbench so that the gauge measuring head contacts the valve stem and applies a pressure of approximately 0.5 to 1 mm. Take measurements at 2 sections in the middle of the stem. Observe the dial gauge from a level perspective. Slowly and steadily rotate the valve stem and observe the extent of the needle's oscillation. Add the total amount of movement to the left and right, then divide by 2 to determine the stem's bend. Note that the chrome-plated portion of the valve stem forms a step and layers with the valve head. Ensure the stem remains straight when positioning it and selecting measurement points. If the bend exceeds 0.05 mm, the valve stem should be replaced or corrected. The corrected deviation should not exceed 0.02 mm. Step 7. After completing the tasks, fill out the work order. Clean up the workspace and restore the equipment. Although the valve stem is a small part, its role is significant. The inspection process involves various measuring tools and requires careful consideration and standardized procedures. Finally, please consider the components of the valve assembly and valve transmission assembly. That concludes this lesson. Thank you all.